A triangle's height is the length of a perpendicular line segment that originates on a side and intersects the opposite angle. Triangles have three heights, each related to a separate base. In right triangles, isosceles, and equilateral triangles, finding the height is easy with one of two methods. In an equilateral triangle only, each height line segment splits a side in half and is the angle bisector of the opposite angle. Here is the equilateral triangle SUN. It has one side labeled 24 centimeters. Since all sides of an equilateral triangle are congruent, we know each side of triangle SUN is 24 centimeters. And we also know each interior angle of an equilateral triangle measures 60 degrees. Notice that each line segment showing the height divides the equilateral triangle into two right triangles. Your ability to divide a triangle into right triangles or recognize an existing right triangle is your key to finding the measure of height for the original triangle. Since a height line segment of an equilateral triangle splits a side in half and is the angle bisector of the opposite angle, we know that the short legs of the newly created right triangles measure 12 centimeters, and the newly created angles measure 30 degrees each. Now we know the measure of all three angles and the length of two sides, the short leg and the hypotenuse. What is the length of the third side? This is a job for the Pythagorean Theorem. We only need our lengths for the Pythagorean Theorem to work. We start by plugging in our known sides, which gives us 12 squared plus b squared equals 24 squared. Now we solve for b. And we find that b equals approximately 20.78 centimeters. The Pythagorean Theorem solution works on right triangles, isosceles triangles, and equilateral triangles, but it will not work on scalene triangles. Now let's look at how we can use the area formula to find the height of a triangle. The formula for the area of a triangle is 1/2 of base times height. If you know the area of the length of a base, then you can calculate the height. Here we have scalene triangle ZIG, with a base shown as 56 yards and an area of 987 square yards. Using algebra, we can take our area formula where A is the area, B is the base, and H is the height, and rearrange it so that we are able to solve for height. Now we plug in our known values and solve for H. This gives us H equals 35.25 yards. Remember how we said every triangle has three heights? If we take triangle ZIG and rotate it clockwise, so side GZ is horizontal, and construct a height up to angle I, we can get the height for that side too. Plug your known numbers into our height formula and solve for H. Our answer, H equals 34.477.